Hello everyone. In this video, I am going to discuss problems on superposition theorem. First problem, find current flowing through 1.5 kilo ohm resistor by using superposition theorem as shown in figure. This is the simple network I am considering, and we need to find current in 1.5 kilo ohm resistor, that is I. Okay. And as for procedure, we know that superposition theorem is applicable for the circuit consist of more than one independent source. Means in this circuit, there are two independent sources, 10 volts and 5 volts. Solve according to the procedure. Solution. Step 1. In step 1, we need to identify the number of independent sources in a given circuit. Step 1. Number of independent sources is equal to number of independent sources is equal to 2. Number of independent sources is equal to 2. Therefore, we are getting two individual responses. Then we are adding the two individual responses. We are getting total response. Therefore, 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 we are getting two individual responses. Therefore, the total response, therefore, the total response capital I is equal to I1 plus I2. Capital I is equal to I1 plus I2, where I1 is the where I1 is the response due to 10 volts, and I2 is the response due to 5 volts. I2 is the response due to 5 volts. This is in step 1. We need to clear the problem. First, we need to identify the number of independent sources. Then the total response I is equal to I1 plus I2, where I1 is the response due to 10 volts source, and I2 is the response due to 5 volts source. Yeah. Then we need to calculate I1. Okay. Now for that, we are considering only 10 volts source and replace this 5 volts by short circuit. Step 2. In step 2, first case 1. There are two independent sources, means we are getting two cases. Case 1, consider 10 volts source acting alone and replace 5 volts by short circuit. 5 volts by short circuit. Draw the circuit according to this case 1 statement. Consider only 10 volts, replace 5 volts by short circuit. Draw the circuit as it is. 10 volts source, sorry, this 5 volts is replaced by short circuit, right? 5 volts we are replacing by short circuit direct line. Okay, and this is 10 volts, 1 kilo ohm, 1.5 kilo ohm, and 2.2 kilo ohms. Now the response in 1.5 kilo ohm becomes I1. The response in 1.5 kilo ohm is I1. Yeah. To find I1, I am following mesh analysis. To find the I1, I am following mesh analysis. There are two meshes. I am assuming two mesh currents. The current in mesh 1 is I1, and the current in mesh 2 is I2. The I1 current is flowing like this, and the I2 current is flowing like this. Okay, then apply KVL in mesh 1. Apply apply KVL in mesh 1. Okay. Mesh 1, 1 kilo ohm resistor, 1.5 kilo ohm resistor, and 10 volts voltage source is connected. I'm starting from this 1 kilo ohm resistor. This is a resistor, means there is a voltage drop. That voltage drop is, we are writing minus. Therefore, it is minus 1000. Current is I1. Next, 1.5 kilo ohm resistor is connected between mesh 1 and mesh 2. Therefore, it is minus 1500 I1 minus I2. Next, coming to the source, current is changing from negative to positive. It is potential rise, plus 10 equal to 0. Then it is minus 2500 I1 plus 1500 I2 is equal to minus 10. This is equation number 1. Okay. Next, apply KVL in mesh 2. Apply KVL in mesh 2. Like KVL in mesh 2. How many elements connected in mesh 2? Only two resistors. There is no active source. I'm starting from this 2.2 kilo ohm resistor. This is the resistor, means voltage drop. For voltage drop, we are drawing negative sign. 2200 minus 2200 I2. Current is I2, and minus 1500. We are writing equation for mesh 2. It is I2 minus I1 equal to 0. Then it is 1500 I1 minus 3700 I2 is equal to 0. This is equation number 2. This is equation number 2. Next, by solving equations 1 and 2, can get small I1 and small I2. Get small I1 and small I2. Enter the values in equation 1. I1 is minus 2500 minus 2500, and I2 is plus 1500 and is equal to minus 10. Enter as it is values in the calculator. Next, equation 2 is 1500 I1 and I2 is minus 3700 and is equal to 0. Okay. Then again enter. We are getting I1 value. I1 is equal to 5.2857 into 10 power minus 3. And I2 is equal to 2.1428 5 into 10 power minus 3 amperes. Then write in milliamperes. 5.2857 milliamperes. I2 is equal to 2.1428 milliamperes. Then we need to find the value of We need to find the value of capital I1. I1 is connected between mesh 1 and mesh 2. Our response I1 is connected between mesh 1 and mesh 2. Therefore, I1 is the difference of I1 minus I2. Therefore, I1 is equal to I1 minus I2. That is equal to I1 is 5.2857 minus 2.1428. 5.2857 minus 2.1428. That is equal to 3.1429 milliamperes. I1 is equal to 3.1429 milliamperes. Okay. Next, case 2. We are finding the value of I2. For that, we are considering 5 volts voltage source and replace 10 volts by short circuit. Replace 10 volts by short circuit. In case 2, consider 5 volts source acting alone and replace 10 volts by short circuit. Consider 5 volt source acting alone and replace 10 volts by short circuit. Draw the circuit again. 10 volts is replaced by short circuit resistors. It is very easy in second case. We are not changing any resistor values, just we are replacing the sources. This is 5 volts and it is 2.2 kilo ohms, 1.5 kilo ohms and 1 kilo ohm. Now the response becomes I2. Now the response in 1.5 kilo ohm becomes this capital I2. Okay, same again. I am using mesh analysis. Mesh analysis. The current is I1. The current is I2. We are assuming in clockwise direction only. Mesh analysis. The currents assuming in clockwise direction only. Yeah. And equation 1, equation 2. In equation 1, in previous circuit, there is a voltage source and we are getting minus 10 here. And in this circuit, there is no voltage source in mesh 1. Then as it is equation by replacing this 10 volts by 0. By applying KVL in mesh 1, by applying KVL in mesh 1 and mesh 2. Mesh 1 and mesh 2. Therefore, the equation here in previous equation 1 put in place of 10 0 as it is minus 2500 I1 plus 1500 I2 is equal to 0. Okay, this is equation number 1. And here in previous circuit there is no source in mesh 2, but in this circuit there is a source in mesh 1, mesh 2, 5 volts, and then is in place of 0, right? 5. 1500 E1 minus 3700 I2 is equal to 5. This is equation number 2. And by solving equation 1 and 2, we are getting I1 and I2. I1 and I2. I1 and I2. Solve these two equations. I1 is equal to I1 is equal to minus 1.071 into 10 power minus 3, that is equal to minus 1.0714 milliamperes. Next, I2 is equal to minus 1.7857 into 10 power minus 3, that is equal to minus 1.7857 milliamperes. Milliamperes. Then we need to find the current I2. Therefore, I2 is equal to same I2 is equal to I1 minus I2, and I1 is equal to minus, substitute I1 is equal to minus 1.071, minus I2 means minus minus becomes plus 1.7857, that is equal to I2 is equal to 0.7147 milliamperes. This is from case 2. Then the total response I is equal to algebraic sum of I1 plus I2. Therefore, the total response total response I is equal to I1 plus I2. That is, I is equal to I1 value 3.1429, is equal to 3.1429 plus 0.7147, that is equal to 3.8576 milliamperes. And this is our total response by using superposition theorem. This is clear. First, we need to identify the number of independent sources. Then, number of independent sources is equal to number of individual responses. To find individual responses, we are considering only one source. Replace all sources by their internal resistance. Here, two independent, two voltage sources. First, we are considering 10 volts. Then we are getting I1. Next, we are considering 5 volts. We are getting I2. Then, by adding I1 plus I2, we are getting total response. By adding I1 plus I2, we are getting total response. Is it clear? Thank you.